Here's a free response question for you. We have this region R here. Let R be the region enclosed by these graphs. The y-axis and the vertical line, x equals 2. So going from 0 to 2, we do our integrating. They don't tell you which one is on top and which one's on the bottom. That is up to you to figure out. So can you do that? Let's see. It looks like this is my cosine function, and then I have a downward opening parabola which has a vertex at 1, 6. That looks right. Okay, so this is the h function up here, and this is the g function here. Okay? Part A, find the area of R. So the area of that region is the integral from 0 to 2 of top, the h function, minus the g function. I'm going to save one step. You can put them in separate integrals if you want to. I'm going to subtract this whole thing here, so that's going to flip that to a plus 2. I'm going to flip that to minus 3 cosine pi over 2x. This is a no calculator problem, so I have to do this by hand. So here, antiderivative of 6 is 6x. Here, bump the exponent up by 1, divide by the new exponent, and the fact that this is an x minus 1 in here is fine because the coefficient of the x is just 1, so there's no reverse chain rule kind of adjustment that needs to be made. Oh, I should have combined these here. 6 plus 2, you know what that is? It's 8. Very good. So that's 8x. That's the antiderivative there. And then the antiderivative of negative cosine is positive sine. No. Is that right? No, it's negative. Sorry. Negative sine of pi over 2x. And then there is a multiple on this x, so I have to divide by that, which is the same as multiplying by its reciprocal. All right, not too pretty. I think we can do it. So 2 plugged in here, 16 minus 2 plugged in here, that's just 2 minus 1 is 1 to the third is 1, so minus 2/3. Minus, plugging the 2 in here gives me pi, and the sine of pi is 0, so that wipes out that term. And minus, what do I get when I plug 0 in here? I get 0 minus 0 minus 1 is negative 1 to the third is negative. So that's negative 2/3 times negative 1 is positive 2/3. And then the sine of 0 is also 0, so that knocks that out. So once you have an all numerical answer, you can leave it like that. So that is totally fine to just leave it exactly like that. I do believe that's 44/3 if you're keeping score. All right. If that seems like a pretty terrible amount of math that you have to do there, please remember that you're going to get a lot of the points by doing the antiderivatives right. So do what you can. Try not to make math mistakes. All right, so part B, region R is the base of a solid. For the solid, at each x, the cross-section perpendicular to the x-axis, that's good news, so that's a dx problem, has an area of this. Find the volume of the solid. Okay, so the find the area of a cross-section kind of solid, you just need to integrate across from wherever to wherever across the area. So in this case, the area had nothing to do with the two functions, which is, you know, kind of a weird way to define an area, but that's it. So we're just integrating across the area. Even when we do the rotation things, our volume formula is always just integrating from wherever x1 to x2 across the area. So it's just that. So that's natural log x plus 3. And this could be natural log 5 minus natural log 3. That's totally fine for your answer. You know, flex your muscles. You could do that if you wanted to, but there's no reason to. It's good. All right. And the last one, oh, could you see any of that? Sorry, is that off screen? So yeah, the integral of the area expression from 0 to 2. And there's the work for what I was just saying there. Part C, write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 6. That's here. So kind of out of room on my page here, but when we rotate that around this line, it's going to make a hollow thing, right? Some kind of fancy bowl or something. So the outside radius is going to be the g function, and the inside radius is going to be the h function. So remember how to set this up? You have to do pi times the integral. We're still taking slices perpendicular to the x-axis. So I didn't have to mess with any kind of dy stuff here. So the outside radius squared. The outside radius is the g function. And since I'm just setting it up, and they said the names of these functions, I don't have to write out all this stuff. I can just call them the g function and the f function here. So g of x, and then there's the shift. So that's pi outside radius squared minus inside radius squared. And that's all you have to do.